Hello guys, welcome back. Today we will start chapter 9 in cybersecurity tutorials. The last time we have been discussing about protecting your networks. How to protect your networks. Generally, we have been discussing about these issues. Today we will start chapter 9, cryptography and public key infrastructure. So that if new for my channel, please subscribe and like for additional chapters to be notified on time. So that today we will discuss chapter 9, generally the science of cryptography in cybersecurity or information security. If any questions or any comments, please come with your comments. I will respond individually for you. Okay, under chapter 9 sections, we will see about cryptography, use tools to encrypt and decrypt data, what type of tools can be used to encrypt and decrypt data, using cryptography to secure communication, what is the definition of cryptography, explain the role of cryptography in ensuring data integrity and authenticity of data, explain how cryptography approach enhance data confidentiality, public key cryptography. We will discuss about public key cryptography in details, so that those and another issues will be discussed on this chapter. Okay, cryptography. Keep in mind that what does mean cryptography. I am asking here to remember or keep in mind in the future slide we will discuss about the definition of cryptography in cybersecurity or information security. Okay, before we are going to define the cryptography, let us see some issues. First of all, securing communication. Information security concern protecting data of information while travel on the network. While you send over the network data or information or assets, there may be securing. Securing so that based on these issues, cryptography science appeared in the later series of in modernization of IT technology. Okay, generally cryptography realized four objectives of security information as you show on this slide. Is the first one, confidentiality. What does mean confidentiality? As the name indicates, confidentiality guarantees that only authorized users can read the messages, meaning that it keeping in secrets. So that only authorized users can read the data. Unauthorized user cannot read the data, meaning that unauthorized user cannot be read the data. Okay, data integrity. The second one, data integrity, is the objective of cryptography. What does data integrity? It guarantees that the message were not altered by unauthorized users. When you send the data or information over the networks, it may be integrity because unauthorized users cannot be altered. So that the second objective of cryptography is data integrity. The third one, authentication, origin authentication. Original authentication guarantees that the message is not foreign, it doesn't actually come from its state. So that it is authentication, meaning that the owners can uh, access the data has actually originated as the expected sources, meaning that the originator of information must come from the legitimate sources. The first one, non-repudiation. Guarantees that the senders cannot refuse validity of the message over sent. The integrity of message is irrefutable by the sender. So those four factors are the objectives of cryptography. Now let us define a cryptography. As you see on this slide, cryptography is science. Making and breaking secret codes. There are two disciplines in cryptography. The first one, cryptography. Second one, cryptology is a science of making and breaking secret codes. There are two disciplines. The first one, cryptanalysis. So that we are discussing about cryptography in this slide. The development and the use of codes that are used for communication privately, meaning was it the meaning of cryptography is the use of codes that are used for communication privately, meaning that you use a case to send over the data over the networks, so you have keep in secret the case to technique of secure communications. For example, cryptology is equal to cryptography plus cryptanalysis. Manual cryptanalysis is the breaking of those codes. Specifically, it is the practice and the study of determining exploiting weakness in cryptographic techniques. This is also breaking those codes, especially the practice study of determining exploiting weakness in cryptography techniques. So that is easy by examining the weakness of cryptography techniques, we can cryptanalysis making. So that those are the two branches of cryptologies. Okay. Cryptography ciphers. Why cyber? By, by the way, cyber is an algorithm that consists of three well-defined procedures to encrypt or decrypt messages. What does it mean encrypt? Encrypt meaning change plain text into some unreadable formats. Decrypt also the opposite of encryption. After the plain text is converted to encrypted or unreadable data, when arrive on the destination, the information of the data can be back to original state. This is called decrypting messages. The following are type of cipher that have been used over the years. The last years we have it was the such algorithms, cipher algorithms can be have been used for the last some years. The first one substitution cipher, third one transposition cipher, the third one alphabetic ciphers. The first one substitution cipher retains the later frequency of original messages. This algorithm done by substituting the letters in frequency of original messages. So that this type of ciphers you have been used in the last some years. The second one, transposition ciphers. In transposition ciphers, like transposition of matrix, transpose of matrix, no letter are replaced. They are simply rearranged. By using rearranged, you can transpose of the ciphers. Second one, alphabetic ciphers. Polyalphabetic ciphers are based on substitution using multiple substitution alphabets. This is a multiple substitution alphabet. As you know this, multiple substitution. So that the substitution is single substitution. The third one, multiple substitution. Cryptanalysis, code breaking, meaning that code breaking. A number of code breaking or cryptanalysis methods exist, such as brute force, cybertext, non-plain text, among others. Several methods are used in cryptanalysis. For example, let us see the several methods of cryptanalysis. The first one, brute force. This is the cryptanalysis try. Our possible case, knowing that eventually one of them will work. This is multiple try to hack the systems, multiple trying or breaking a code is finally gain access to your system. So this type of method is called cryptanalysis or code breaking. The third one, cybertext. Cryptanalysis has a cybertext of several encrypted messages but no knowledge of understanding plain text. But without no knowledge of understanding of plain text, the cyber analysis several encrypted messages. By using this, they made a cryptanalysis. The third one, non-plain text. Cryptanalysis has access to several messages and knowing something about plain text underlying the ciphers. The first one, chosen plain text. Cryptanalysts choose which data encryption device encrypts the observed or cipher output. So that The crypto analyst chooses which data encryption devices of the cyber text output. Chosen ciphertext, the crypto analyst can choose different ciphertext to be encrypted, has access to decrypted plain. The type of crypto analyst is also powerful and by using a chosen ciphertext. The last one, meet in middle. The crypto analysts know a portion of plain text and corresponding ciphertext. With modern technology, security of encryption lie in security of case, not algorithm. In modern technology, so that not algorithm, it is rely on a case. Two terms that are used to describe case, for example, key length and key spaces, also called key sizes. This is called key sizes, which measures the in bits. In this course, we will use term key lengths. Key space, this is the number of possibilities that can be generated by specific key lengths. Specific, as you see on this, for example, uh, 56 bits, meaning that the key space is 20 to the power of 56 key spaces of possibilities. For example, look, 72 bill around 70 billion key spaces are available for these uh, cyberspaces. As a key length increase, the key space increase exponentially. Cryptographic hash function. Cryptographic hash is used to verify and ensure data integrity. Hashing is based on one-way mathematical functions that are relatively easy to compute but significantly harder to reverse. And when you using hash functions, it is not reversible. Once you encrypt it to unreadable formats, it cannot be reversed to original status. Cryptographic hashing function can also be used to verify authentication. Hash function take variable block of binary data called message, reduce pixel length as condensed representation called hash. Every time the data changed or altered, hash value also changed. Okay, cyber hash operation. Mathematically, the equation h is equal to h of x is used to explain how hash algorithm operate. So that everybody knows this mathematics in high school. Uh, Cryptography hash function should have the following properties. The input can be any languages. Maybe look the inputs can be any language. The output has fixed language, but the output has a fixed language. H of x is relatively easy to compute for any given of x. H of x is one way and not reversible. H of x is collision free, meaning that two different input values will result in different high values. My function is due to ensure the integrity of messages. The input data has not been changed accidentally or intentionally. There are well-known hash algorithms. There are 128-bit MD5 SHA-1, SHA-2. MD5 is 128-bit biggest one-way function that produces 128-bit hashed messages. MD5 is considered to be legacy algorithm. It is recommended that it can be used in study. Okay, SHA-1 very similar to MD5 hash function. Several versions exist. For example, SHA-1 120-bit hashed message and slightly slower than MD5. While hashing can be used to detect access data change, it cannot be used to guard against delivered message. There is no unique identifying information from sender in hashing procedure. Hash message authentication codes. To authentication integrity assurance, key hashed message authentication code (HMIC) used. To add authentication, HMIC use additional secret keys as input to hash functions. Only sender and receiver know the secret keys, and output of hash function now depend on the input data and secret keys. Only parties who have access to the secret key can complete the biggest of HMS functions. If the digest that is calculated by receiving the device is equal to the digest that was sent, the message cannot be altered. Encryption. These two classes differ in how they use case. Symmetric encryption, asymmetric encryption algorithm. There are two types of encryption algorithm. Uh, when we see symmetric encryption algorithm use the same key to encrypt and decrypt data. In these algorithms, uh, the same key, the two encrypt and decrypt. Yeah. They are based on premise that each communication party know pre-shared keys. By using pre-shared keys, asymmetric encryption algorithm use different key to encrypt and decrypt data. They are based on the assumption that two communication parties have not previously shared secret and must establish secure method to do so. The asymmetric algorithms are resource intensive and slow to execute. Symmetric algorithms use the same pre-shared key to encrypt decrypt data. Today, summarized encryption algorithm commonly used with VPN traffic. This is because symmetric algorithm use less CPU than asymmetric encryption algorithm. When using symmetric encryption algorithm like any other type of encryption, the longer will take for someone to discover the key. Most encryption keys are between 112 to 256 bits. Use longer key for more secure communication. Symmetric encryption algorithm. Symmetric encryption algorithm. Encryption algorithms are often classified as block cipher, stream cipher. Block ciphers transfer while the fixed length block of plain text in the common block of cipher of 24 or 128 bits. A stream cipher encryption planes 1 byte or 1 bit at a time. Well-known symmetric encryption algorithm include data encryption standards, triple days, advanced encryption standard, and so on, so that asymmetric encryption algorithms. Asymmetric encryption algorithm, also called public key algorithm, are designed so the case is used to encrypt is different from key that is used for decryption. The decryption key cannot, in a reasonable amount of time, be calculated from encryption key and vice versa. Symmetric algorithm use public key and private key. Both keys are capable of encryption process, but the complementary paired key is required for decryption. This process is reversible. In thus encrypted with public key require private key to decrypt. This process enables asymmetric algorithm to achieve confidentiality, authentication, and integrity. Asymmetric encryption, confidentiality. Asymmetric algorithm are due to provide confidentiality with pre-shared passwords. The confidentiality objective of asymmetric algorithm initiated when encrypted process is started with public key. The process can summarize using formula public key, encrypt plus private key, or decrypt key is equal to confidentiality. When public key is used to encrypt data, the private key must be used to decrypt data. Only one host has private key. Symmetric encryption, meaning authentication. The authentication objective of symmetric algorithm is initiated with private key encryption process. The process can be summarized using formula private key encrypted plus private key decrypted is equal to authentication. When a private key is used to encrypt data, the corresponding public key must be used to decrypt data. Because only one host has a private key, only that host key have encrypted the message providing authentication of sender. When host successfully decrypts message using public key, it is trusted that private key encrypted the message which verifies sender. Symmetric encryption integrity. By considering integrity common to asymmetric encryption process provide message confidentiality authentication integrity. So that this is also very important but resource intensive, but it has a confidentiality integrity and authentication is very better use of asymmetric encryption algorithm. Diffie-Hellman is a symmetric mathematical algorithm algorithms that allow two computers to generate identical shared secret without having communicated before. The new shared key is never actually exchanged between the sender and receiver. How? Because of both parties know it, the key can be used by any algorithm to encrypt traffic between two systems. Security edge is based on facts that use unbelievable large number in its calculation. Unfortunately, asymmetric key systems are extremely slow for any sort or bulk encryption. This is why the common to encrypt bulk to traffic using symmetric algorithm. Public key infrastructure. Using a digital signature. Digital signature is a mathematical technique used to provide authenticity, integrity, non-repudiation in the form of code signing in digital certificates. Digital signatures are commonly used in the following situation: code signing, digital certificate. Code signing is due to verify the integrity executable file when downloaded from vendor websites. Digital certificates are used to authenticate the identity of system exchange confidential data. There are three digital signature standards. Algorithm is used for generating and verifying a digital signature. Digital signature algorithm, reverse shams Allman algorithm, elliptical digital signature algorithm. Digital signature for coding signing. Digital signature are commonly used to provide assurance of authenticity, integrity of software code. Executable files are wrapped in digitally signed envelope, which allows the end user to verify signature before installing the software. Digitally signing code provides several assurances about the code. The code is authenticity is actually sourced by the publisher. The code cannot be modified since it left the software publisher. Digital signature for digital certificate. Digital certificate enable users host origination to securely exchange information over internet. Specifically, digital certificate is used to authenticate and verify that users can send message or who claim to be. Digital certificate can also be used to provide confidentiality for receiver with mean to encrypt rely. Public key management. When establishing an asymmetric connection between two hosts, the host will exchange their public information. Trust to their party-owned internet validates the authenticity of public key using digital certificate. The third party usually confidential that is difficult to follow. From that point forward, an individual who trusts the third party simply accepts the credentials that the third party issues. Public key infrastructure is an example of trusted third-party system referred to as certificate authority. The CA issue certificates that authenticates the identity, organization, and users. These certificates are also used to sign message to ensure the message are not to be compared with. Public key infrastructure. Public key or PKI is needed to support large-scale distribution identification of public encryption keys. The PKI framework facilitates high scalable trust relationship. It consists of hardware, software, people, policy, procedures needed to create, manage, store, distribute, revoke digital certificates. Not all public key infrastructure certificates are directly received from CA. Registration Authority (RA) subordinate says certified by root of CIA to issue certificate for specific use. Public key authorized system. Many vendors provide CA servers as managed service as end-user product. Organizations may also implement private key using Microsoft Server or OpenSSL. CA issues certificates based on class lists which determine classes which how trusted in certificate is. The class number determines how rugged the produce ways that verify the identify holder when certificate was issued. The higher class number of more trusted certificates. Public key infrastructure system. Public key can be formed different topology of trust. Simplest is a single root public key topology. One larger network PKI may be linked using two basic authentication. Cross-certificate CI technology. These appear to be model in which individuals establish trust relationship with other CA by cross-certifying CA certificates. Hierarchical CA topology. The highest level of CA is called root CA. It can issue certify to end users in subordinate CA. Interoperability of different PKI vendors. Interoperability between PKI entities supporting services concern because many CI vendors have proposed and implement proprietary solution instead of waiting for standard to develop. To address these interoperability concerns, the IETF published the Internet X 509 Public Infrastructure Certificate Policy and Certification Practice for Frameworks. Request for comment 2527. The X9 the X.509 version 3 standard defines the format digital certificates. Certificate enrollment authentication revocation. All systems that leverage the PKI must have CI public key called the self-sign certificate. The CA public key verify all certificate issued by CI. It is virtual is vital for proper operating of PKI. The certificate enrollment process begins with CI certificate as retrieved in band over network. The authentication is done out of band using telephone. The system enrolling with public infrastructure contacts CIA to request obtain digital identity certificates for self to get CIA signed certificates. PKI public infrastructure application. Some of many applications of PKI are SSL, TLS certificate based peer authentication, HTTPS web traffic, secure network traffic using IPS VPN, control access to network using wireless standard, secure email using simple MIME protocol, secure installation messaging, approved authority application with code signing, and securing base list of device also. So those are the public infrastructure applications. Encrypting network translation. Threat actors can use SSL to introduce regulatory compliance violation, virus, malware, data loss, intrusion attempt in network. Other SSL-related issues may be associated with validating the certificate of web server. When this occurs, web browser will display secure warning. PKI-related issues that are associated with security warning include validate data range, signature validation error. So that, for example, valid data ranges. Certificates specify not before and not after dates. If the current date is outside the ranges, the web browser display messages. So that encryption and security monitoring. Network monitoring because more challenging when packets are encrypted because HTTP introduces end-to-end encryption. HTTP traffic via TLSSL is not easy to pick into new user traffic. Here is a list of some of things that security analysts can do. Configure rule to distinguish between SSL and necessary traffic, HTTPs and HTTPs or traffic. Enhance security through server certificate validating using CR. Implement anti-malware protection and URL filtering. Deploy Cisco SSL appliance to decrypt SSL traffic and send it to intrusion prevention system. Chapter summary. Okay, thank you very much for today's. We have discussed a little more about chapter 9, generally cryptography concepts. This is not enough. Please read more about cryptography concepts. This is just that inform you about the science of cryptography only. Under chapter 9, we discuss about cryptography in public infrastructure as a general, as you see on these slides. So that in the next chapter, I come with a new chapter in chapter 10. We discuss about all of this, the hash functions, what are the subordinates of hash function MD5, SALT1, SALT2. We discuss about all those things. Okay, the type of algorithms we have discussed about symmetric algorithm and asymmetric algorithm. We have discussed about the difference and the similarity, the concepts, advantage, disadvantage. Okay. We discuss about the digital signature and the digital certificates. We also discuss about a public infrastructure. Okay. Finally, we discuss about the SSL configuration of rules and certificate, server certificates. We have discussed in details. Okay. The terminologies or the commands can be used in the slides. Also, those terminologies are keywords. So that if you have any questions, please post your comments on my comment box. I will respond individually for you. Thank you very much for today's. Until next time, we will come with chapter 9, chapter 10, chapter 10. We will come in chapter 10. Thank you very much. Until next time, bye. If new for my video, please subscribe and like.